Hello guys, welcome to today's video. In this video we're going to talk about the tangent and normal to a curve. The tangent and normal of a curve. So the equation of a tangent to a curve at a point x1, y is given as, when we talk about the equation of a tangent, to a curve, tangent to a curve at a point, we're given the points x1 and y1. Now the point is given as x1, y1. Now the formula for the tangent of a curve at a point this is given as y minus y1, which is equal to f prime of x1 into x minus x1. Now f prime simply means the derivative of the function that will be given to us. Either you call it the y dx, y prime, or f prime. It means we are differentiating that function. Now, we also talk about the gradient of the normal. Now, the formula for the gradient of a normal, is given as minus 1 all into the f prime of x1. Now, the equation of a normal, talking about the equation of a normal, or we say of the normal, is, equation of the normal is y minus y1, which is equal to minus 1 into the f prime of x1 into x minus x1. So this is the formula. You need to remember the formulas. The equation of a tangent, which is given like this, the gradient of a normal, and the equation of the normal. So I'm going to take an example using this formula. Now, taking an example, given the question, we are asked to find the equation of the tangent and normal to the curve y is equal to 3x squared minus 5x at the points 1 and minus 2. Okay, now we're going to solve this. Now the question says find the equation of the tangent and normal to the curve if a function is 3x squared minus 5x at the points 1 and minus 2. The point, this is our x1 and these are y1. 1 is x1 and minus 2 is y1. So we're going to solve it like this. So start solution. Okay, now we can write this as y is equal to f of x. I said that you write it as y of f of x is equal to 3x squared minus 5x. Okay, now the f prime of this, which is when you differentiate this function, 2 will multiply 3, which will become 6x. Then you subtract 1 from the power, you become 1 minus x is raised to the power of 1. 1 minus 1 is 0. Anything raised to the power of 0 is 1. So 1 multiplied 5, we're going to have 5. So this is the derivative of this. And our formula says, the formula of the tangent, so we're going to say the tangent at the points 1 and minus 2 as the equation. The formula is y minus y1 into f prime of x1 into x minus x1. And our x1 is given as 1. So putting it into this equation, we are going to have the f prime of x1 will be equal to, wherever we see x, we put 1, which is 6 into 1 minus 5, which is going to give us 6 multiply 1 is 6. So we're going to have 6 minus 5, which is equal to 1. So our f prime of x1 is giving us 1. So now we're going to put it into this equation. Into the equation, which is y minus y1, which is equal to the f prime of x1 all into x minus x1. So now our y was not given to us, so we have y minus, remember the point was given to us as 1 and minus 2, and our y1 is minus 2, so therefore here will be minus 2 into the f prime of x1 is 1, so I'm going to put 1 here. 1 into x was not given, x minus, then our x1 is given as 1. So we continue, minus multiply minus is going to be plus, so we're going to have y plus 2, which is equal to 1. 1 multiply x is x, 1 multiply minus 1 is minus 1. So collecting it here become y is equal to x minus 1. When plus crosses are equal to changes to minus, so we're going to have y is equal to x minus 3. So this is the equation of the tangent. So this is going to be, you can write this as the equation of tangents. So we're going to write now, the question says we should find the equation of the tangent and the normal. So we solve for the tangent. So solving for the normal, solving for the equation of the normal is going to be equation of the normal. Now the normal at a point 1 and minus 2 as the equation, so the formula for the normal is y minus y1, which is equal to minus 1 into the f prime of x1 into x minus x1. Now we know that our f prime of x1 is given as 1, so therefore we're going to have y into y1 is minus 2 into minus 1 all into 1, x minus 2, because our x1 is given as 1, so here will be 1, sorry for that. Okay, so at this point we're going to have y plus 2, because this multiply this will become plus, will be equal to y plus 2 minus 1 divided 1 is going to give us 1 minus 1 into x minus 1. Okay, we're going to multiply all through, so we're going to have y plus 2, which is equal to minus 1 multiply x is going to give us minus x, minus 1 multiply minus 1 is going to give us plus 1. So at this point we take y, so that's y is going to stand on its own, so we're going to have y is equal to minus x plus 1 minus 2, so we're going to have y equal to minus x plus 1 minus 2 is minus 1. So therefore this is the equation of the normal. So this is the first example. We're going to take another example right now. The second example is, the question says find the equation of the tangent to the circle to the circle giving x square plus y square equals to 2a square. Then at the points, giving the points A and A. So we can put it as f of x will be equal to the function, which is this. So this is an implicit function, so we are going to differentiate it using the implicit form. So when we differentiate this, we are going to have 2x, and when we differentiate y squared, we are going to have 2y into the y, the x, so it is equal to 2a squared is a constant, and when you differentiate a constant, it's going to give us 0. So now let's divide the x stays on its own. So we're going to have 2y the x will be equal to 0 minus 2x. So 2y the x will be equal to minus 2x. We're going to have dy dx will be equal to minus 2x all into 2y. This is going to cancel this, so therefore at y dx will be equal to minus x and y. And we thought we were given at a point, so given at a point a, so therefore our dy dx will be equal to minus a all into a, which is equal to, when this cancels this, we are going to have minus 1 left. So now we're going to look for, the question just says we should just look for the tangent, the equation of the tangent. So for us to solve for the equation of the tangent of the circle, at the point which is a, as the equation, which is the formula for tangent. The equation of the tangent is y minus y1, which is equal to the f prime of x1, which is also known as the y dx, into x minus x1. So our y1 is given as a, so we're going to have y minus a, which is equal to the f prime of x1, which is our dy dx, is given as minus 1. So we have minus 1 into x minus a. So we're going to have y minus a will be equal to minus this multiply this minus x. This multiply this is going to become plus a. Alright, then we're going to have y minus a will be equal to minus x plus a. So collecting like terms, we're going to have y will be equal to minus x plus a. When this crosses over, it changes to plus a. So our y will be equal to minus x plus 2a. Now this is the answer to the equation of the tangent of the circle. So therefore this is the equation of the tangent to a circle. I really hope this video is helpful.